sorry about the delay getting started here. We are going to do some speed and velocity practice. We said yesterday that speed is the scalar one, SS, speed scalar, and that velocity is vector, VV, so it's kind of easy to remember that it's going to be your velocity that's going to need to have direction, and it's going to be the speed that does not, because scalar means no direction, vector means include direction. Yes?
Vector commences crimes with both direction and magnitude. Oh yeah!
Oh yeah. All right. See, and that's exactly what I hope you remember with it. All right. So we have our little triangles here. So velocity, it says the V is velocity, D is displacement, T is time, right? And then over here, it just kind of shows the equations. If you would solve for time, here's your equation. If you need to solve for displacement, here's your equation. And then over here, it's kind of showing, instead of covering up, it has it highlighted. So if I need to solve for distance, going across means that multiplication. Going, stacked on top of each other like this, you're showing division, like a fraction. And then again, like this, if I cover up speed, we get distance over time. It actually has the equations written out for you. Not always will you have this kind of setup, but you'll always have the triangles that you can use. So it's just the exact same as we had before when we used our density. All right, so let's take a look. So the directions say determine what question is asking for, whether it's speed, velocity, distance, displacement, or time. So really we have 5 things we could actually be solving for. We're going to circle it in the question, and then we're going to underline the information that's given, and then we have to choose the equation. If we're solving for speed or velocity, those equations are our standard equations, so there's no rearranging. If we have to solve for distance, displacement, time, then we would have to rearrange it. All right. Always making sure we're including our units, and if it is displacement or velocity, then we have to include direction. Okay? So, stay with me, do not work ahead, it's not going to gain you anything. And I want you to do what I'm doing, and I know that some of this is going to be maybe too simple, and that's fine. This is still kind of setting us up for when things get a little bit more complicated, that we have those good strategies to take care of this. You are making me nervous that is going to fly off and hit Abigail in the head. Stop it.
It has yet to do that. Exactly.
Yet.
But the time, yes, there's the key word, yet. Okay? And we would prefer that it not go in the back of Audrey's head or anywhere on Abigail either. Okay? Okay, thank you. All right. So it says calculate the average speed if a golf cart travels 140 meters in 10 seconds. All right, so what are we going to circle? What is it that we're solving for? And be with me because I'm just going to randomly call on people.
Speed.
Okay, so we're going to circle speed. Oh, shoot. You know what? I'm going to move mine down for a second. Come on. I want to make sure I have the triangle stuff there. Okay. So let me go back. Circling speed. Charlie, give me something that is given in this problem.
140 meters.
Good, 140 meters. Give me something else is given. Okay. Now, this one was pretty easy because we didn't have to decode anything. It comes right out and says, what is the speed? So speed is going to be our unknown. With speed, we hopefully have a distance and a time also. So which one of these looks like a distance? And obviously you can probably tell by the units. Will Naylor?
140 meters.
Okay, 140. For our time, what's it look like, Anthony?
10 seconds.
Okay. When I do them over here, I usually don't put the units just because it kind of clutters it up. If you want to, go for it. I'm not saying not to, but at this point you don't have to. So I'm just going to write the equation here. So if I'm solving for speed, it's distance over time, or I can use my triangle, and it's d over t. On these, if you, my calibration's a little off. If you want to make like the little division sign, it's still off. Let me fix it. It was that far off until I got too precise. Just so you remember, so in the triangles, if you wanna put the little division symbol, and then if you wanna put the multiplication sign going side to side, so you remember that those get multiplied, that might be, a nice strategy for a reminder. So here, divide, here is multiply, divide, multiply, divide, and multiply. Again, it's kinda, this one might show up better. Divide there, multiply there, right? Those are a little bit small, but, okay, so if I'm solving for speed, it's gonna be, that's too messy to stand. It's gonna be, speed is distance over time. So I'm gonna have d over t. And so you can have it like this, or you know, you can also write it like d/t. Both of those mean division. Please don't do d and then the symbol. For some reason, when people do it that way, they make little mistakes, and I'm not sure why. I've never quite figured out why that is, but I've noticed it a lot. So do the fraction version, okay? So now we just plug in, and it says that, plug it in. So we take our d, which is 140, and our time, which was 10, and when we do that, what do we get? What do you get, Brooklyn? I think I caught myself. Caitlin?
14.
Okay, good. All right, now, when we do the division, that's our magnitude or our number. But remember, whatever we do to our numbers, we also do to our units. And so if this 140 was the meter and the time was a second, we have to include that in our final answer. Whatever we did to the numbers, we do to the units, and we get that new derived unit of the meter per second. So that's the final answer. Do I need a direction with this? What?
No,
Why?
because it's a speed, not a velocity.
Very nice. Speed is scalar, so no direction is needed. Okay? All right. So that's pretty basic. We don't have to rearrange anything, which is kind of nice. All right. Let's look at number 2. So it says, it takes Charlie 30 minutes to run 40 kilometers east to the grocery store. What is his velocity? So what are we solving for here, Ethan? What's this question asking for?
How long it takes for Charlie to run, what his velocity is, I don't know.
Very nice. What is his velocity? So we circle that. Dylan, give me something that's given in this problem.
Okay, so we have 40 kilometers, and then it says east is the direction.
Good. So we got that 4
And it
kilometers
also says
east.
velocity,
Oh, okay.
Which is a direction, which means it's not speed, because vector commits its crimes with both direction and magnitude.
Oh, yeah. All right, Selena, what's another piece of information that's given on this paper?
Charlie took 30 minutes.
Very nice, 30 minutes. Okay, so V is my unknown, and the velocity is displacement and time. So hopefully I have a displacement, which I do. Which one of these is a displacement, Austin?
The 4 kilometers east.
Okay, so 4 kilometers east. And then what is the time, Cheyenne?
30 minutes.
Okay, so I'm going to just use my standard equation. It's V over, or equals D over T, right? We don't have to rearrange anything. And so now I'm just gonna plug in. I have, my velocity equals, 4 over 30. Okay, and what do you get?
How do you plug this in calculator form?
You put your top number in first, and you hit the divide symbol, and then you hit 30. So always put your top number in
All right.
first.
I don't know if I got the right answer, but it says 0.133333 repeating.
Okay, so when we're doing practice problems, I don't care how you round, all right? If it's a lab, that's when I care, like to the 10th or to the 100th. So usually I just go like a couple places, so 1.3 repeating would be fine. If you want to put the 0.13, that's fine too. I will take either way as long as I know that that is 0.13. All right, what else is next? Because this is one of the, out of the 3 points is what this answer is showing me right now. What do we have to include, Breeze? What do you think? What is part of a velocity answer?
Like minutes or times.
Good, so we have to have units, right? Okay, so my 4 was a kilometer. My 4 is a kilometer, my 30 is a minute. So whatever I did to my number, that's what I do to my units. So it's a kilometer per minute, which is a little weird, but that's what the units are in the problem, so that's what we go with, okay? That's what we have to go with. Are we done? What else do we have to include, Will?
Direction.
Okay, and what is the direction?
East.
Good, and I just kind of ran out of room, so I'm gonna just tack it on there at the bottom. 0.013 kilometers per minute east is a 3-point answer. All parts are included there. Okay, any questions? Good. All right, let's take a look at number 3. Okay, it says, how much time would it take for the sound of thunder to travel 2,000 meters if sound travels at a speed of 330 meters per second? Dylan, what are we
Alright.
solving for?
We got speed, and we got meters, and we got.
Okay, hold on, stop there. So speed and our meters, which is probably a distance or a displacement, are given. So then what are we solving for in this problem? Audrey, what do you think?
You're solving for time.
Okay, so now time becomes our question mark. We have a distance or a displacement, we don't know quite yet, and we have speed. Well, since it's speed, I know that that D is distance, right? And so now I just fill these in. I have 2,000 for my distance, and for speed, I have 330. So now I'm setting this up for time. So since I have my screen is kind of split, I'm gonna just kind of draw my triangle on here. So it is D at the top, and it's over speed and time. So we know that this means division and this means multiplication. So I'm solving for time. So the strategy is we cover up time and we get D divided by S, or distance over speed. Okay, so now I'm just gonna plug it in. T equals my 2,000 over my 330.
So which one do we cover up?
So we solving for time, so you cover up your T. Whatever it is you're solving for, that's what you cover. And then that leaves us with D divided by S.
Alright.
Okay, so that's how we got our D divided by S. We plugged in our 2,000 for the D, and we plugged in our 330 for the S. Okay, what'd you get?
6.06.
Okay, I'll put it over here, 6.06, so we could even round that to 6.1, or honestly, if you just put 6, I'd be fine. You know, as long as you're giving me enough digits so that I know that you've got the right answer, that's fine. Now, from here, what do we do? What do we need to include to make this a complete answer? Dylan, what do we have?
need the units.
Absolutely. So let's take a look at what we did with the units. Or excuse me, what we did with the numbers. Because this is how we get our units. So, if I look at this logically, in this problem, do you see any time unit? Even if it's part of another unit, do you see that anywhere? I see a couple nods. Cole, where do you see it?
In the speed,
Okay, and what is it?
I guess.
Alright, he sees the S in seconds. Okay, do you see any other time units anywhere? So our units are gonna be the second. Here's why it works. If our units are the meter over the meter per second, well, anything over itself will cancel out, so then we're just left with S. So the math backs up the logic. All you really have to do is pick out the time unit from that problem, which is why, again, the units are so important. So ask yourself, what are some time units? Minutes, seconds, hours, days, weeks. Well, which one of those do you see? So even if it's part of the speed or the velocity, it's still the time for this problem. And so you're allowed to take that unit out and have it be your time unit. Okay, this part that I have, the work, I don't need you to show me that. Like, if you want to put it on your paper so you know where it comes from, this is the only thing. Sometimes this confuses people. I'm just doing it to show you where the units actually come from. So if that's confusing, don't worry about it. Just make sure if you can pick out the units that you include them. Okay? All right, let's look at number 4. An ant can travel approximately 30 meters per minute. How many meters could an ant move in 45 minutes? Okay, so let's see. Owen, what is something, what are we solving for here in number 4? Okay, so we're solving for meters. So we don't have an equation for meters, but what does meters represent? A speed, a velocity, a distance, a displacement, a time? What do you think? Okay,
Distance.
okay, it's gonna probably be a distance or a displacement. Do you see a direction there? No, so it is gonna be a distance, not a displacement. All right, hold on everybody, I think. Have I missed anybody? Okay, Dylan, give me one thing that is given in this problem.
One thing that is given, we got the meters, but we have like 45 minutes.
Perfect.
Which is a time limit.
Awesome. All right, what is the other thing? Emily, what is one more thing that's given?
30 meters per minute.
All right, so we are solving, like Kate said, for distance. We are given the speed of 30, and we are given the time of 45. So now, I am going to solve for my D. So in our triangle, you have to cover up the D. And then what are we left with? What are we gonna do with our other 2 variables? What's that triangle tell us to do with them? What do you think, Caitlin? Good. So we're gonna take our speed times our time. So D equals 30 times 45. And what does that answer give us? $1,350. Okay? And we're solving for distance. So what do you see for a length or for a distance unit in this problem? Charlie?
Meter.
The meter. All right? It actually says how many meters, so that kind of helps, but it's also right there in the speed as well. Here's how it works out. Our 30 was meters over minutes, right? Times our minutes. Well, this is like putting it over itself, so these cancel out and you're left with the meter. Again, if that confuses you, don't include it in your paper, but if it helps to kind of show where this comes from, include it. Do we need a direction? No, because it's, a meter, but it's for speed. Okay, if it was displacement, we would. All right, here's what I'd like you to do. Flip over to the back, and we have about 12, 13 minutes. What I'd like you to do is to finish those 4 and then bring them up to me to show, or if you have questions before then,